So space getting crowded. You know, we hear numbers like there's thousands of Starlink satellites out there. Like when a rocket's going up to space, does it have to worry about banging into satellite?
You know, when you think about, you know, Star Wars, Star Trek, all of these things, and then what the future would look like from a space perspective, this is coming, and this is coming very fast.
There's a lot of emphasis as well on your capabilities now that we have Russian spy ships, we have dark vessels, we have a different geopolitical situation.
Every naval service has exactly the same problem. I have a finite number of assets that I can deploy. I need to know where to deploy them. And I want to deploy them before an event happens, not after an event happens.
Welcome to Siren Investigates, the podcast that investigates the cutting edge of technology around investigations. I'm John Randles, CEO of Siren. Today I'm joined by Fintan Buckley, CEO and founder of Ubotica. Welcome, Fintan.
Thank you, John. Good to be here. Good to be back in Galway.
Great to have you. And let me introduce Fintan first of all. Fintan has 25 years experience in technology, VP of engineering with Scenario Technology, around construction design, was a senior engineer at Trintech Technologies. The firm is an Irish company that rolled out chip and pin technology, was one of the early founding employees of Partis Technology around chip design, and is a graduate in computer science from Trinity College Dublin. And today we're here talking about in-orbit intelligence, satellites, AI, and Ubotica is in the forefront of this, detecting threats, environmental events. You look at. Tell us about Ubotica. Give us some of the background and how did you end up in the satellite business?
Yeah, well, I have to correct you there first, John. Someone's going to look at this and say he's much older than someone who's spent 25 years in the business. I'm actually more like 40 years in the business, or close on. And it's been a great ride, you know. Been at the vanguard of technology here in Ireland. Graduated from the first computer science class and coming out of Trinity very early on. So it's been fantastic in terms of being a part of how the country has changed and how we have embraced technology and actually developed a climate within Ireland of actually being entrepreneurs in the tech business. And how I got into this play with Ubotica, actually started here in Galway. With the older viewers would remember Digital Equipment Corporation, DEC, which is based here in Galway, and I think in Clonmel as well. And that closed down probably 1991. And the gentleman who founded Partis Technologies worked here, and so he had the vision, all right, which very few people did at this day, at that time in Ireland, to actually start his own company. And it was a company that was initially doing design services and chip design, and then morphed into doing other things. But what he did was he brought together a team of young people, myself included, and encouraged us, right, not only to be leaders in the technology space, but eventually to encourage us, actually, you could go out and do your own thing.
Yeah.
And so moving on, some of my colleagues from Partis, when they left Partis, went on to found a company called Movidius. Movidius was a leader in the development of technology that would apply AI algorithms on the edge, and particularly in cameras. And Intel acquired that company in 2016. And at the same time, there was a vision to say that technology that was deployed in cameras, on drones, etc., could also be applied in satellites, and particularly Earth observation satellites.
Right.
So that was the influence. And just to finish, it was actually the opportunity to work with people who I'd worked with before.
Yeah.
Right. To do something different and to do something new.
Yeah.
So that was the impetus.
Really interesting how many companies have come from that digital factory shut down in Galway over the years. It's just all over Galway. The impact has been massive.
Well, I might say it's all over Ireland. It really has been phenomenal, the change. And before that, I worked in the US, and I came back to Ireland in the early 90s, not to Partis Technologies. And actually, it was, very difficult to get a job in Ireland in the tech space in the early 90s. And it was certainly novel that someone was thinking about starting their own company.
Yeah.
I was fortunate to say not to think about the risks involved, just to say, yeah, I'm going to go for this.
Yeah.
And it was a fantastic ride, and actually, fantastic learnings out of this, and met fantastic people who I must say I'm delighted to work with. And when I worked with Partis, we were raising our children.
Yeah.
Now I'm working with the same people. We're raising our grandchildren. It's like,
that's a great journey.
Yes, it is fantastic.
Yeah. And when you think about the technology in Movidius, it was in cameras and drones. What was the inspiration to take it from something so earthbound like a drone or a camera and put it in space? That's a leap.
It certainly is a leap, but it was part of this was driven from conversations with the European Space Agency, who actually realized even back in 2016, 2017 that the traditional way of developing technology and capability in space had to change. So the traditional method of particularly developing silicon chips, was to actually design from the bottom up circuitry that was resilient and resistant to the environmental environment that you would experience in space. The drawback to that is it's expensive, and it's slow, and the volume of product that you're going to sell is extremely low. So the idea was, first of all, determine, could you take something that had been designed for terrestrial applications and actually fly it with minimal mitigation? And that was the start of where we went to. So, we had about 2 years of evaluation of the silicon in Siren, in hospitals, anywhere we get access to radiation generating equipment to do this. At the time, it was the most complex piece of silicon that was ever evaluated through the European Space Agency. And at the end of that, with some mitigation, but external to the device, we were able to fly it and have flown it successfully and have continued to fly it successfully. It's been remarkably resilient to on orbit, and it kind of replicates what SpaceX are doing. That they have turned the whole paradigm and methodology of developing products for space. Instead of saying we're going to design this to the nth degree so it's never going to fail, they design it, they fly it, and they learn from the failings, and they go again and they go again. And the outside of that is that you end up with product quicker. So that was kind of where the journey started.
That's interesting, because it sounds like you've been working towards this point for a long time, where now AI is very topical. Satellites are super topical, coming together, and how they address things like national security challenges is a huge topic of interest. Do you feel that you've been building up to this moment since you founded Ubotica?
Would I have predicted it? No. But are we essentially coming to a point of a perfect storm where there's a demand, there is technology, and there's capability to actually deploy it? I think the answer is absolutely yes. To elaborate a little bit about the particular application space, it's on Earth observation satellites. So it's satellites that are on orbit to image the Earth, producing images for human consumption, but also for scientific consumption as well. It's not just your RGB images that humans can consume, but it's for soil analysis, chemical composition of soil, and things like that. The traditional Earth observation market is, there's a concept we use called mowing the lawn. Is that the satellites are just taking pictures, right? And hoping that there's value in the pictures. Okay, that's the traditional way. smaller, more agile companies are getting into the tasking business, where a third party can buy satellite time to say, I want to get an image of this location. Okay, so that's kind of a shift. But where we're really going after is the real time application of these EO satellites. So an event is happening, right? Or an event may happen, and we want to get eyes on this event from space and be able to make decisions when we detect the event about what to do next. Yeah, that's really where the application of AI comes in.
Okay. So then you're doing more in space than any other satellite in terms of processing data before it gets to Earth. Is that true?
Yeah. So on the first more incarnation of this is the ability to analyze the image data, to extract the insight or the intelligence from the data, and get that to Earth extremely quickly. So last year we launched our own satellite, which was it's a commercial satellite. We sell access to the satellite, but it was primarily to prove this paradigm, to prove that it was possible to do this. So, we have now proven that from image capture to insight on the ground to the end user, we can achieve in 10 minutes. Which is a real shift in what's been capable to date, and that's using a range of technology, from our own AI capability, our own AI models, using ISL for inter-satellite links to get that data down, and then the orchestration of this is important as well.
Yeah. So 10 minutes, that must really change the workflow of the people that are consuming this data and the kind of use cases they can process from that.
Yeah, and when we talk about the perfect storm, we've always known we can do this, but the question has been, what is the application or applications where you need this real-time capability?
Yeah.
And as it's one thing about technology, but the question is, who's going to pay for it, right? And who's going to value getting this information in relative real time? And the application space we're focusing on is maritime security or maritime domain awareness, which is, the one place on Earth where it's very difficult to get cameras to understand what's going on.
Yeah.
Right. And, in Europe, especially, we're seeing, there's a vulnerability throughout Europe in our maritime waters in terms of the security. And, we're looking at it's, smuggling, drug smuggling, people smuggling, but much more importantly, it's the security of the infrastructure that's either on the water or on the water. And this is where our technology is going to play a key part going forward.
Right. So you're talking subsea cables, you're talking oil installations. There's a lot of massive investment going into offshore wind farms. So you're part of that protection of that space.
Exactly. And the mantra we use is seabed to space, right?
Okay.
Clearly, we're not doing all of this, right? But we see ourselves as a key part of this. And, at the end of the day, what we are working to do is to assist in the provision of the intelligence or the insights to allow the security services to deploy their resources in the most efficient manner.
Right.
Right. We talk about it here in Ireland, but Ireland is a small player in this, but every naval service has exactly the same problem. I have a finite number of assets that I can deploy. I need to know where to deploy them. And I want to deploy them before an event happens, not after an event happens. And that's really where the satellite data, the satellite insights come from.
Fantastic.
And play into this.
And we've seen, a lot of people do different things with drones, with planes, but there's a lot of sea out there, isn't there?
There's a huge amount of sea. But, the people we will work with will have this technology. They'll have the underwater drones. They'll have the on-water drones.
Yeah.
Right? They'll have access to manned vessels as well. And then we're providing the space thing. So it's really the coordination of how, what do I do with all these resources to make sure I protect while I'm trying to protect?
Yeah. And I've read it, there's a lot of emphasis as well on your capabilities now that we have Russian spy ships, we have dark vessels, we have a different geopolitical situation. How has that affected your business in the last 6 months, 3 years? Whatever you're comfortable talking about.
Well, 6 months, clearly the world has changed. And within Europe, it has changed dramatically. In terms of the spotlight that's been shone on Europe's lack of investment in its defense/security space. And that has, within Ubotica, forced us to rethink. Okay, instead of being a platform play, we see the real opportunity is in the security space, in the defense space, and that's what we're going after with our technology. It's clear, Europe is underinvested. That investment is coming. It's clear that the demand is there for the technology, and the threat is there. Right. And in fact, just reading on the train coming down, there was an event on in West Cork last night, and they're talking about this. And there was a discussion around, well, who should pay for the security, right? Particularly, let's say, of the undersea cables, right? Is it the companies that own the cables? Is it nation states or whatever? But the bottom line is, if we can't secure our infrastructure, it will have drastic impact on the whole of society. And it's not just your Facebooks and your Googles, right, who own the cables. It's everyone will suffer, right? And that's where the Europe has to beef up its capabilities, and Ireland is part of that. We need to do this.
And I think the term that people haven't appreciated until now is critical infrastructure. That it is actually part of our economy. These cables that are under the sea, the connectiveness of our country. And you see that now in the kind of investment discussions that are coming, where people are saying, you know what, these are under threat. They're under threat because they're valuable. Not because they're not valuable. If they weren't, nobody would be protecting them, but they're incredibly valuable, aren't they?
They are. And some of it may be a little bit of scaremongering, but, the threat is there. Right. And, if you take a kind of a look at this from an amusing point of view, you say, if everyone lost access to their Facebook accounts because the cables were cut, there'd be an uprising in the area, right? So that's how much this infrastructure is actually used, right? And then you look at the real uses from an economic point of view, the amount of financial transactions that actually go through these cables, the data, right, that we all rely on, right? Your business, my business, we all rely on these cables to actually conduct our business. If suddenly those cables are under threat, then there's going to be a problem in the economy. So that's why we have to recognize that the world has changed. Within Europe, our allies may not be quite our allies anymore, and we do need to take more responsibility for actually defending this ourselves and protecting it. And it's not saying we need to be aggressive, we need to be offensive, but we need to be aware, and we need to be able to take steps if we think the infrastructure is under threat, and that's where our technology really comes into play here.
Fantastic. And as well, I think people always think of their own Facebook page, for example, when you're showing your age there, but you talk about Facebook.
I'll talk about MySpace.
Exactly. But if you think about the number of data centers in Ireland alone, and 1/3 of the data they reckon in the EU is in Ireland. So, and then the new investments in AI and things like that. So they're all dependent on those cables in many ways.
I mean, we're dependent on the cables. We're dependent on the energy infrastructure that's both above the sea, but also the interconnectors that are running between Ireland and France and Ireland and Scotland, whatever. So in the Baltics, one of the gas pipelines was damaged 2 years ago. And those are the types of things that we can help. Right. In terms of identifying threats before they happen and allow the security forces to take action.
So you're saying you launched your own satellite last year. Talk about the technical challenges. How does somebody say, a company based in Dublin, we're going to launch a satellite? Talk us through how that works. Or
remind me to tell you a little bit of a story about that at the end. So what we did was we partnered with a company in the UK who we had previous track record or operation with. We designed the payload. they integrated the payload into the satellite. So, we paid for the payload, right? We paid for them to actually manage the building of the satellite. We paid for them to actually manage the steps in terms of putting that satellite on orbit, including buying time on SpaceX. Can't remember which one it was, to actually put the thing in orbit. So so we don't actually manage the satellite. Let the operator actually do all of that for us. But the key thing was designing the infrastructure and designing the the orchestration, software orchestration, and how the accelerator was getting integrated into the product. So yes, it was a journey, and actually we because we do talk about this is our satellite, and it is our satellite, even though we pay someone else to operate it. And the day before the launch, and I guess it shows how good our PR was, we got a panic phone call from Enterprise Ireland, wanted to know had we applied for the licenses to actually launch and fly the satellite. Right? And so there was a bit of scurrying going around, because I don't know if you recall, the first Irish satellite, AirSat-1. Right? So actually they had to bring I'm not sure it was a bill or whatever, to actually to the DAL to actually grant approval for the satellite. So there was all this panic, but actually it was the license were obtained to Spain. So right. But it was a bit of a panic at the end of the day on that.
Interesting.
Yeah,
Interesting.
absolutely. Yeah.
So you'll have your license well flagged up front in future.
Well,
and it was,
and it was all taken care of, but it was kind of funny. I was sitting on the plane getting these phone calls. Where's your license? Where's your license? So we were actually
interesting. So somebody packed this satellite onto a SpaceX rocket. It gets shot up.
It gets put into orbit. We were actually lucky, because it's a bit of a lottery. Because these satellites, they go into essentially it's like a Pez dispenser where it just shoots them up, bang, 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 bang. And so we were one of the first off, which means you get into a higher orbit. Which means you get a longer lifespan. But eventually the thing actually starts to get closer to Earth, and eventually will decay. But the real excitement that we had over the satellite, everything was going really well. The commissioning happened within a couple of days. And then we learned for the first time about a thing called the South Atlantic Anomaly, right? Which is what's the word I'm looking for? It's a phenomenon, right, that can have an impact on your spacecraft, right? And we actually the spacecraft flew through the anomaly, and actually after that the batteries ran into a problem in terms of charging. All right, so we had about 3 weeks where we're working with the operator in terms of what are we going to do about this, right? Because essentially the satellite was still alive, but it wasn't particularly functional, right? And so this is where you kind of realize actually how things can go badly wrong. And so eventually, because we have, between ourselves and the operator, we have a mirror twin of the satellite on the ground. And so we're doing all sorts of tests trying to replicate on the satellite. And they said, okay, we're going to have to do the nuclear option here, which is actually just hit the button, totally drain the battery. If it comes back, right? In the process of draining the battery, the thing came alive again.
Really?
Yes. And then we were,
So this is the ultimate reboot.
This is the ultimate reboot, and actually the operator said to me afterwards, they said, well, how do you think, our staff, worked with you and managed this whole situation? And I said, actually, back to him, I said, how do you think we managed? Because our business could have been totally snookered if this thing didn't come alive again. So I said, how do you think we managed, and how calm were we? And actually, we were very calm. We said we just let them do their business. But that was the most interesting part of the whole thing, was actually when something did go wrong. Actually, how do we manage as a team and with our partner and through the recovery process? But other than that, we have an excellent team ourselves. between the team we have in Delft to do our space engineering and our AI team in Spain. But actually, we have a good partner as well.
Yeah.
So I think we got through it.
Fantastic. You can't be real world implementations. You're never going to simulate that, are you?
No, not this. And at the end of the day, it was a technical fault, right?
Yeah.
But actually, because you can't touch the thing is so far away.
Yeah.
Right. That's your problem. Right. And no matter how good your digital twin is, it's actually.
Yeah.
Yeah.
Yeah. And have you come across that problem again when it come across that space, or is it just a known issue that you deal with?
Well, it hasn't happened again. So there's some of the software that was implemented after that has mitigated against it.
Okay.
Yeah.
Fantastic.
And this is part of when you're pushing the edge here. When you're actually trying new things, it's these things are going to happen, and it's like all engineering. When something goes wrong, how do you deal with it? Right.
Yeah.
And it's not a case of panic. It's actually, okay, let's go at this methodically and try to come to a solution. In this case, we were lucky.
Fantastic.
Yeah.
And so a big part of what you're doing now is around critical infrastructure around Europe. It sounds like your focus market right now as well.
Yeah. Europe and some in the Far East as well.
Okay.
Yeah.
So, so we touched a little bit about the attitudes to defense and critical infrastructure having changed in the last 6 months. Talk about that in terms of, the amount of funding available, the amount of interest. This is now, I was just reading this morning as well about a lot of commercial satellite companies now in the US are getting business outside of the US because people are investing in their own intelligence rather than depending on somebody else for intelligence. Do you see that as a big driver in your business right now?
So first part of your question in terms of do we see demand? Do we see funding? The answer is absolutely yes.
Yeah.
Do we see companies who have traditionally not been involved in maritime security coming into this space now? Absolutely yes. Do we see realization that satellite technology and satellite capability has a key role to play in security, in particular maritime security? Absolutely yes.
Yeah.
For us, what the key thing for us is partnership, right? So we will not provide the complete solution to maritime security. We will provide an element of that.
Yeah.
Okay. So that's where we see our drive, our focus, and actually the demand is actually for in some case traditionals, in some case non-traditionals who are involved in this space, and we see essentially consortiums that will actually solve this problem. It's companies like Siren doing. I'd probably insult you if I would say the more traditional analytics, but the terrestrial-based analytics.
Yeah.
Coupled with then the analytics or the insights coming from the drones underwater, on water, and the satellites. And the key thing is figuring out what is going to happen.
Yeah.
And it's the analytics to determine from a mass of vessels that are in a particular body of water, which are the ones that are potential threats, right? And then what do you do and how do you follow them and whatever. So where we're going is phase one is the analytic has been able to generate the insight from the image, but much more important is two things. One is what we call the dynamic tasking, which is the satellites making the decisions themselves about where I'm going to image and how I'm going to image.
Okay.
Right. And so that's using AI to predict ahead of time, actually, what is the area I've been tasked to image an area of interest, but actually it's cloudy. Right. Or, it's cloudy on the right, on the right of my field of view, but not on the left. But actually, so imaging and then making a decision in real time, right, to actually orientate the satellite so the camera is pointing one way or the other. All right. But that's phase one. Second phase is actually, okay, I'm over an area of interest, and actually, there's something here, and we need to track this. We need to keep an eye on it. Okay. Now it's communicating with other satellites within the same constellation to say, when you're over here, right, this is where you need to look. This is what you're looking for, right? And actually, predicting where a vessel of interest is going to go, and actually, tasking the satellites to track this as it moves. So essentially taking the human out of the loop in terms of decision making. Third element of this is what we call the virtual constellation. So this is where you take satellites of different modalities, so different imaging capabilities from different operators, right? And you link these into a virtual constellation so that you can task and orchestrate without the humans in the loop to actually use all of the assets you have available to actually generate the insight. So that's
the AI in the satellite isn't just about image processing and getting it down to a small piece of data for transmission. It's about, how do I behave as a satellite? And how do I link to other satellites, and how do I, assign tasks?
That's correct. I mean, and you have to be able to do these decisions real time. I mean, because you can't, with the way the orchestration and the management currently works in terms of satellites, you could be hours to days from the time you say, I need to image this, and then you get onto the operator and they say, well, we have a queue. Well, the satellite has a finite battery life and we can't image it on this orbit, so it'll be the next one. So in order to be able to generate the real-time tracking and insights that you need the decisions to be done on the satellites themselves.
Right. So that's an incredible amount of trust you have in the AI, because they're effectively managing the satellite on your behalf.
Yeah.
Right. How did you build up that trust, and how do you test something like that?
Okay. So it's an excellent question. So first of all, right, you have to have human trust.
Yeah.
Right? And so when we develop this technology and we work with our partners, right, they have to trust us to say that we know what we're doing. Okay. The other thing, in terms of how you orchestrate the satellite, I mean, you do have to have bounds on it.
Yeah.
Right? It's like any piece of technology. You have to constrain the limits of what it can do. Yeah. With AI, it's even more important because it's extremely difficult, not impossible, to have an AI model that is 100% accurate 100% of the time.
Yeah.
You need bounds and you need constraints. We do have technology that we've developed, which is part of our trust, to allow us independently to look at the decisions that the AI algorithm has made, and then decide, are we going to act on this? Right. So yes, I mean, trust is a very important part of what we do. But in general, though, so yes, orchestration of the satellite is something where we take the human out of the loop. But in other aspects, particularly the insights that we bring to ground, that's part of a bigger picture.
Yeah.
Right. And with the fusion of data sources from various sensors and data points, it's a collective decision about what you do with that information.
Yeah. So look, this space technology seems to be definitely having a moment right now, and obviously you're super close, that you're right involved in it. What are the hot things that you're seeing at the moment? What are the trends? What are the things that that you'd like our listeners to know about that they probably have no idea about?
So what is happening here and has been accelerated is the deployment of AI algorithms on board satellites. I mean, this has come from 0 5 years ago, in terms of particularly for Earth observation satellites, to now. We were the pioneers of this, right? And there are quite a number of companies that are doing this because they see it's capable, they see the abilities of doing this. Okay. the next steps of this are, as I've talked about, are the decision making on board, not only for extracting the insights, but also for what to do next and how to orchestrate and manage other satellites within the same constellation. I mean, what's coming after that is data centers in space. What's coming after that is tugs in space to reposition satellites. Within a short number of years, right? Space is going to look like Dublin Harbour in terms of, tugs and vessels and things being repositioned and whatever. So, when you think about, Star Wars, Star Trek, all of these things, and then what the future would look like from a space perspective, this is coming, and this is coming very fast.
Interesting.
Yeah. No, yeah.
And so space getting crowded. We hear numbers like there's thousands of Starlink satellites out there. Like when a rocket's going up to space, does it have to worry about banging into satellite?
Well, you have to think about it is, these satellites get refreshed, so they have a lifespan of 3 to 5 years.
Yeah.
Right, and then they deorbit, if you like, and then this is integrated in when it comes close to the Earth's atmosphere.
Right.
So there's always a constant refresh. So is it getting crowded? No.
Okay.
Yeah.
So, sometimes you hear scaremongering about space junk and things going so fast, like the movies that there's something heading towards, the International Space Station. But
well, that's a problem.
Okay.
So it's, the space debris is a real problem, and there are companies that are looking to map the space debris, because the damage that even a small piece can actually cause to something like the space station is significant.
Right.
So, what's coming now, which isn't very exciting, right? But actually is maneuverability, right? Is these small satellites, which to date are simply just in an orbit, and is the requirement to actually able to maneuver, to actually take evasive action on.
Okay.
On satellites because of the space debris. So yes, that is a problem.
Yeah, and they'll probably need AI on board as well to be able to manage.
Yeah, so we do have our own camera, right, a space camera, which is designed specifically for that. Which actually, instead of looking on ground, looks ahead, looks behind, and actually tries to spot debris, and if necessary, take action.
Yeah, and so Europe, in the context of an international space race where obviously the US is super active, SpaceX has launching so many rockets into space. China, super active, activity on the moon. Where does Europe fit, and what can Europe do to catch up?
So I think Europe needs to focus on what Europe needs.
Yeah.
Right, which is its own capabilities in space. We have our Galileo, which is the GPS equivalent. We have our Sentinel constellation, which provides imagery not in real time, but it's there. But we also need our real-time capabilities as well, and it needs to be done on a sovereign basis. I mean, right now what's happening is that, sorry, not sovereign, but with a multi-sovereign basis. We have countries putting their own constellations on orbit. So Italy, Portugal, Greece, Poland, right, are doing their own, but actually just very focused on their own borders. And we need to actually build that to being a Europe-wide constellation of satellites. And that's where our virtual constellation comes in.
Right.
To actually provide the type of infrastructure we need for the security that we need on our borders.
Yeah. And are there moves in Europe to bring that together? Because obviously the EU is often the place where we meet to bring initiatives together at this area.
Yeah, and we work very closely with Enterprise Ireland, and particularly the European Space Agency team within EI, to try and promote this, and actually we are making good headway on this to try and bring this to the ministerial level within Europe, to actually to focus the attention on why this needs to be done at a Europe-wide level as opposed to at a sovereign, because it is expensive, right? Of course, putting these constellations in, they have to be refreshed, right? But But against that, the cost of putting one satellite in space and operating is far less than actually the cost of one chip. Right. So to actually get this message to say this is expensive, but it's worth it, and it's not expensive as other methods of and more traditional methods of providing security.
Yeah. I think what you're talking about, refreshing satellites, that's something that a lot of people wouldn't be familiar with. You kind of think a satellite goes up there, it's there, but you're saying 3 years?
3 to 5 years,
Okay.
For low orbit satellites.
Yeah.
Right. So, and these things are relatively small. They're essentially, they're a camera and control.
Yeah.
The base technology that operates the satellite is quite low tech.
Yeah.
Right. And the cost of putting them in there, is actually not that expensive relatively, right? It's just the design effort and whatever.
Yeah. So the traditional satellite, we think of doing, communications or satellite TV, satellite phones, they're operating much higher.
So they would be GEO orbit satellites. So they are much more expensive and obviously have much longer lifetimes than the low orbit satellites.
Yeah, fantastic. So what advice would you give a young entrepreneur, young engineer looking at the space in?
All right. Yeah. But okay. We talked about this. We'll split this. So engineer, I think, irrespective of the discipline, I think engineering is a fantastic career. I won't call myself an engineer because I'm a computer scientist, and engineers are very particular on this. But in general, this is a fantastic career, right? Ireland is a fantastic place to actually be an engineer. The opportunities are really fantastic, not only in space but anywhere. Entrepreneur in space is a slow burn.
Yeah.
Right. We've been at this since 2017, and it's really taken to this year for the opportunity to really crystallize to where the growth is going to come from. So, you need patient backers.
Yeah.
Right. As we both have. And you need trust as well. You need trust in your colleagues. You need trust in the people who are investing in you, and you need trust in your customers as well. Most of all, you just need a lot of patience.
Yeah. No, the work for Atlantic Bridge, who are funders of Siren and of Ubotica.
Exactly.
So they like deep tech, and they're patient investors as well.
Yes, correct.
And in terms of the opportunity, like obviously it's been a long time coming in terms of space having its moment, but what you're envisaging of space tugs, of much more activity in space, it sounds like it's just going to become much more a part of the everyday infrastructure of industry, isn't it?
There's absolutely no doubt about this. You in space you will have the ultimate clean room. Right, so manufacturing in space is going to happen. The recycling of and reorbiting of even low orbit satellites is going to happen.
Yeah.
The ability to put people on the moon is happening. The ability to put people on Mars is happening. Tourism is happening. So all of this is happening, and it's happening at a very, very fast rate. And primarily, it's because of the realization that actually there's another way of doing things. It's not actually focusing on the traditional design cycle for space products. Is actually we can do things much faster and actually much cheaper.
Yeah, that's fascinating, and that kind of goes back to some of the testing you had to do around radiation, because the environment you're operating in up there, anything you can share about the levels of radiation compared to what it's like down on Earth?
The main thing that you're dealing with are potential bit flips, right? Which actually can also happen on Earth, right? In fact, there's a number of famous cases. One was during an election in Europe where they used electronic voting, and a candidate, much to his surprise, got 4,096 votes more than he expected to get.
Okay,
right. And if you're an engineer, you'll know a bit must have flipped to actually cause that to happen.
Yeah.
Right.
Wow.
It's also happened in early models of self-driving cars, which was much more dramatic in terms of resulted in fatalities where people couldn't turn off their cruise control. Sorry, not self-driving, cruise control. They couldn't turn it off. So, and then the same thing happens in space. So to deal with that, you're using actually the same method you're using in cars, that you'll have multiple copies, and you will have voting to decide what you're going to do, and then you will have techniques to look at the power that's going to your devices as well, and make sure they shut off for if you have voltage surges and things like that.
Fantastic.
Yeah.
Look, Finn, has been a fascinating conversation, in-orbit intelligence, AI, satellites, how that intersects with national security. Thanks for joining us on the Siren Investigates podcast.
Thank you. Enjoyed this.